Okay, this is part 2. It's also important to be able to evaluate logarithmic functions using our knowledge of exponents. So remember, if we have an exponential equation here and a logarithmic equation, I need to be able to move back and forth, and then I'm going to use that to solve. So in this example right here, the relationship between the exponent in the first equation and the value of the log, if our base is 10, we have log base e, or log base 10 of e is equal to the exponent 11.8 plus 1.5. So they are the same. So in other words, a logarithm is simply an inverse. Let's use our knowledge there to see if we can't solve or evaluate this logarithm. We have to find the value of log base 2 of 8, we must first set the expression equal to x. So we have log base 2 of 8 is equal to x. We can now rewrite that as an exponential equation. So we have the base of 2 to the x power is equal to 8. And remember, we worked problems like this where we had to have a common base. Well, I can rewrite 8 with a base of 2. So we have 2 to the x is equal to 2 cubed. So remember, our exponents can be set equal to each other, so we have x is equal to 3. So if I was asked to evaluate log base 2 of 8, I know that that is 3. All right, let's work some practice problems there. Our first step is going to be set it equal to x. So now I will rewrite the equation. So I have 2 to the x power is equal to 4. Sorry, I'm trying to get back in focus. Sorry about that. And now I'm going to rewrite that with a common base. So I have 2 to the x is equal to 2 squared. And I can set my exponents equal to each other. So the log base 2 of 4 is 2. Okay, on B, I'm going to set it equal to x. 4 to the x power is equal to 64. And remember, this to this power equals this. I can have a common base of 4 here. 4 to the third power is 64, so x is equal to 3. All right. For C, I have a base of 5, and I've set it equal to x, so my base of 5 to the x power equals 625. I need to rewrite with a common base. And 5 to the 4th power is 625, so x is equal to 4. For D, I'm going to set that equal to x, and that gives me the base of 2 to the x power is equal to 2 to the 10th power. I have my common bases, so that's going to be x is equal to 10. Alright, for E, we have log base 4 to the x power is equal to 8. They both need to be rewritten here to have a common base of 2, so that's 2 squared times x. A can be written as 2 to the third power. Set my exponents equal to each other. Divide both sides by 2, so x is equal to 3/2. For F, we have log base 9 of 3. Set it equal to x, so I have 9 to the x power is equal to 3. Now remember, when there isn't an exponent there, it's to the first power. I need to rewrite with a common base of 3. 3 squared is 9, and a power to a power is equal to 3 to the first power. If I set my exponents equal to each other, I have 2x is equal to 1. Divide both sides by 2, so x is equal to 1/2. Alright, a few more examples. Now remember, when we had fractions, we did something a little bit different to get them to have a common base. So I'm going to set it equal to x. I have 3 to the x power is equal to 1 over 27. Well, I need a common base of 3. I know that 27 is equal to 3 cubed, and I can move this to the numerator by making the exponent negative. So that's 3 to the negative 3 power, and set your exponents equal to each other. So x is equal to negative 3. All right, on H, we have first going to set it equal to x. We have the base of 8 to the x power is equal to 1/4. My common base here is probably going to be 2, so I'm going to rewrite that. 2 to the third power is times x, is equal to, remember that's 1/2 squared, so to move that to the numerator, I'm going to make it a negative exponent. Set your exponents equal to each other, so I have 3x is equal to negative 2. Divide both sides by 3. X is equal to negative 2/3. All right, and one last example. Again, I'm going to set it equal to x. My base is 25 to the x power is equal to 1/125. So I need to have a common base. I can rewrite 25 as 5 squared. I can rewrite 125 as 5 to the third power. And now I need to move it to the numerator, so it's going to give me 5 to the 2x power is equal to 5 to the negative third power. Again, set my exponents equal to each other, and solve for x by dividing both sides by 2. So our answer there, x is equal to negative 3/2.